we're going to be talking about geometric sequences and their differences from an arithmetic sequence, and also how a geometric sequence is similar. We talked about in Unit 4, which are exponential functions. So we're going to review an arithmetic sequence, and for exercise 1, they give us a recursive function. First term's 5, and they want us to list the next 3 terms. So looks like the first one's 5, and then each next term is going to be the last term plus 3. So to continue that, I'm just going to add 3 to every next term, and that'll give us the next 3 terms. Now to do part B, it says to find the 20th, and then they don't want us to list all 20. So again, if we want to find the 4th term, we count it up by 3 times. So if we want to find the 20th term, what we have to do to find that 20th term is we got to write down what the first term is, take that term, subtract 1, and multiply by the difference. So to find 20, it's going to be 8 over the 1, which is 5, plus 19 times the difference, which in this case is 3. So our 20th term is going to be what this equals, which in this case would be 62. So that's our 20th term. Now, when we're talking about a geometric sequence, those are going to change by multiplication and division. So you'll see that they have in the box, it says R. They call that a common ratio. And a ratio, again, could be an example of a fraction, which, again, leads us to believe the multiplication and division. So if you look at exercise 2, we're trying to find a number that we can multiply to get from one term to the next, and then finish what the sequence is. So in the case of this, I know 2 times 3 is 6, and 6 times 3 is 18. So we'd end up with 54, and then we would do 162. And then my common ratio in this case is 3. Now, some people might be unsure as they're looking at this. Remember, if you do or you are changing signs, it's going to be negative. So to get from 4 to 20 would be times 5. In this case, this will be negative 5. And then you can finish that by multiplying by negative 5 each time. So our common ratio is going to be negative 5 for this one. Now this one does decrease, and it looks like it's dividing by 2, but you are multiplying by a value. And if you do get stuck, and you're trying to figure out what number you would multiply 16 by to get 8, you could do it in reverse by taking a calculator, take the term, the second term, and if you divide it by the first one, that'll give you the decimal, or you can change it to a fraction form. So every time you multiply 16 by 1/2, you're going to get 8. 8 times a half would be a fourth. Half of 4 is 2, and then half of 2 is 1. So our common ratio for this one is 1/2. So expect to see some where you might have fractions. Now moving on from there, if you take a look at exercise 3, we're going to do something similar to what we did in exercise 1. So they want us to find the second, third, and fourth terms. They tell us the first term is 3, and then our rule for the next term, it's the last term times 2. So if we do for the second term, the first term is 3, 3 times 2 would be 6, 6 times 2 would be 12, 12 times 2 is 24. So we are multiplying by 2 every time. Now, to find the 20th term, that is going to be the first term, which in this case is B1, and we're going to be multiplying that by that common ratio, and we're going to do that in the case of the fourth term, we have to do it 3 times, so we're going to subtract 1 from the amount of times we're multiplying by that ratio. So the 20th term for this is going to be the first term, which is 3, times 2, and 20th would be 20 minus 1, which would be 19th power. So I can type this in the calculator. And that would end up being 1,572,864. That would be our 20th term. Now the last one we're going to look at is exercise 5. And we talked about this before. This is a discrete function. So discrete meaning that we're only going to have those values that we come up with in the sequence. So they tell us our first term is 16. So I'm going to go ahead and make a little table for this. So we're going to have our term, which we'll call n. And then we'll have what we get after we put in that term. So like our first term is 1. This would be 16. We're multiplying by 1/2, so half of 16 would be 8. It says in the question, plot the first 6 terms. So I'm going to do the first 6. And you want to check your, looks like we're going up by ones here. We have 6 spaces. Going up we have 1, 2, 3, 4, 5, 6. So they give us just enough. So we get 116, which would be up here. 2, 8. 3, 4. 4, 2, 5, 1, and then 6, 1/2. Now we don't connect these, again, because it's a sequence, and these numbers here represent the number in the sequence, which we would call the y value. So it's different than that exponential function, but you can see it does resemble, if I were to connect it, it does resemble that graph. So the big idea for today is making sure that you realize that a geometric sequence is a change in a sequence by multiplication or division. But also remember, if you are asked to graph a sequence, you just put points in because there are no other values. Sequences only use whole numbers, counting numbers, starting at 1 and working your way up.